Okay. In last class, we see how sound produce, sound needs to travel medium speed of sound. Now we see terms related to sound waves. Sound travels in the form of waves. Do you know waves? So this one is a wave. This is a wave. This is a sine waves. It is called a sine waves. Okay. So these waves are studied in detail the sound in the form of waves in higher classes. Waves are characterized by three basic quantities, that is frequency, amplitude and time period. Let us take the example of periodic vibration of a simple pendulum to explain the terms amplitude, frequency and time period. Although a simple pendulum does not produce sound waves, the you can hear this will help you understand the basic terms. This one is the amplitude. This is the amplitude upper and this lower. This is the amplitude. And next we see the simple pendulum. A simple pendulum consists of a small metallic ball called bob, suspended by a long thread from a rigid support, such that the bob is free to swing back and forth, to and fro motion. The motion of the bob of a pendulum from one extreme position to another extreme position and back is called one oscillations of the pendulum. For example, in this figure, the motion of the pendulum bob from one extreme position, that is B, and to the another extreme position C, and back to B is called one oscillations. Then next, amplitude of the pendulum. As the pendulum oscillates to and fro motion, the maximum displacement of the bob, this one is the maximum displacement. This maximum in simple pendulum, the maximum B and C are the maximum displacement of the bob from its mean position. This is a mean positions. Mean position on either side is called the amplitude of the bob. In this case, the displacement AB and AC are the maximum displacements. So this AB and AC are amplitude of the pendulum, and this is denoted by, that is, the amplitudes of simple is A, capital A, and is measured in meters. Its unit is meter. Which an object oscillates in the air, the amplitude of the oscillation gradually decreases due to the resistance of air. Next, time period of the pendulum. The time taken by the bob of a pendulum to complete one oscillation is called the time period of the oscillation. So the bob B to C and come back to B, that is called the time period of the pendulum. The time taken by the bob of the pendulum for one complete oscillations, that is called time period. As long as the amplitude of oscillation is small, the pendulum takes equal intervals of time to complete each oscillations. It is denoted by T. The symbol of the time period is T and is measured in seconds. Next topic is frequency. The number of complete oscillations made by a simple pendulum in 1 second is called its frequency. The frequency's SI units is Hertz, named in the honor of German physicist Heinrich R. Hertz. It is denoted by N or F small n or small f. A frequency of 1 Hertz is 1 oscillation per second. When a simple pendulum makes 4 oscillations in 1 second, then its frequency is 4 Hz. Then let us we see characteristics of sound. Characteristics of sound are pitch, loudness, quality. These three are characteristics of sound. But two main characteristics are pitch and loudness, which in turn are determined by the frequency and amplitude of the wave respectively. We say the pitch. Pitch is the characteristics of sound by which you can distinguish a shrill sound from a grave, that is harsh sound. Even though two sounds have the same loudness, shrill sound and grave sounds are same loudness. Pitch is a subjective measurement. However, the pitch of a sound depends upon the frequency of vibrations. The pitch of the sound produced by an object vibrating with a low frequency is low, and the sound is called grave sound. When grave sound is produced, the pitch of the sound produced by an object vibrating with a low frequency is low. That is called grave sound. So low frequency, low pitch. So it produces grave sound. The pitch of the sound produced by an object vibrating with a high frequency is high, and the sound is called shrill sound. That means high frequency makes high pitch, so it produces shrill sound. This is a vibrations pattern, and these are all waves. Thus, the higher the frequency of the sound, the higher will be pitch, and vice versa. For example, the voice of children and women is shrill as compared to the voice of men. This is because children and women have short vocal cords, which therefore vibrate with a high frequency to produce high pitched shrill voice. Men have large vocal cords that vibrate with a low frequency to produce low pitched grave or flat sound. The wings of the bee and mosquito vibrate with a high frequency. Hence, the sound produced by them is shrill and high pitched. When the skin of a tabla or strings of a guitar are tightened, they give out a sound of higher pitch than when they are loose. We take a flute. In a flute, sound is produced by a vibrating column of air. So the frequency of vibration is changed by choosing the holes of a flute that changes the length of the air column. When more holes of the vibrating flute are closed, a note or a sound of a particle frequency of lower pitch is produced. When fewer holes of the flute are closed, a note of higher pitch is produced. So, when higher pitch is produced when fewer holes of flute are closed, higher pitch is produced. Then next we see the activity, a Zoltrang activity. Things required are you take 6 or 8 bowls or tumblers and 2 drumsticks or pencils and take water. First you take 6 or 8 bowls or tumblers, arrange them in a semicircle. Fill them with water, not a same level of water. It fill different levels, increasing and gradually from one end to another. Take a pencil or drumstick, strike the bowls gently. strike all of them in succession, we observe that striking the bowls causes the air in the bowls to vibrate. The shorter the column of the air, the faster the water vibrates, producing a higher pitch. As the height of the air column increases, the pitch of the sound gets lowered. We conclude that this type of bowls are arranged in this type. Then we conclude pleasant sounds of different pitches are produced in Joltrang. Next, we see the loudness. It is a common experience that when you shout, you produce a louder sound. Similarly, when you whisper, you produce a feeble sound. Loudness is a characteristic of sound by which a loud sound can be distinguished from a faint sound even though both have the same pitch. It is measured accurately by amplitude of vibrations of the sound source. It has been found that loudness of sound is directly proportional to the square of the amplitude of vibration producing the sound. So, if the amplitude becomes twice, loudness increases 4 times. So, loudness is equal to amplitude square, amplitude power 2. When you strike the drumstick, drums softly, its skin vibrates with a smaller amplitude and soft sound is produced. So smaller amplitude soft sound is produced. When you strike the same drum hardly, its skin vibrates with a greater amplitude and a louder sound is produced. So in this case, we strike softly, so the sound produce soft sound. In this case, we can you strike the drum harder, so the skin vibrates greater amplitude and a louder sound is produced. So large amplitude gives loud sound. There are other factors also that affect the loudness of sound, like surface area of the vibrating object, distance from the vibrating object, density of the medium, etc. That you will study in detail in higher classes. The loudness of sound is measured in a SI unit called decibel, dB. The following table gives some idea of the loudness of a sound coming from various sources. This one is the rusting of leaves. Its decibel value is 10. Loudness very faint. This is whispering, 20 decibel loudness, very faint. And normal conversation loudness level is 40 to 60 decibel. Loudness moderate. Loud music 90 decibel. Loudness is very loud. In heavy traffic level is 90 decibel and loudness is very loud. Pneumatic drill, that means it's work on air column, 100 decibel, very low. Aircraft engine 140 decibel, painfully loud. Rocket at takeoff, its decibel is 200 decibel level. Loudness level is 200 decibel level. Loudness is dangerously loud.